Facebook Live yesterday. That, you know, that's where we talked about RAF a little, today's to-dos and where we see a lot of the future of technology going. And what I'm going to
more people coming on. Great. Welcome, Jeff, Mita, Andy.
welcome, welcome, welcome. We are going live on YouTube. So one thing I'm going to ask people to do is if they can go to, when I get this YouTube link going, if they can go to the YouTube place and, you know, like the video and follow us. That way we can get, you know, more engagement and bring more people into the community to support, so that we can provide more support to clean tech companies. So if you are here, I'm dropping the YouTube link in. Go ahead, go there and check it out live, like it. And if you want, I'm going to start sharing it on my social media network and platforms that I have here. But feel free to share it on yours and, you know, call attention to, you know, what CleanStart's doing with the to-dos, and to also call attention to RAF Electronics and the cool technologies that Dick is going to be talking about today. So without further ado, I'm going to share my screen, or let's go present.
So Giovanni, we're the Society of the Hats. So you need to get a hat to wear during these things. So get a silly hat.
Sure, I'll be sure to get one next time.
Okay.
Hey. I see
I was
Jeff's
looking
in.
around for my propeller cap, and I couldn't
Yeah, right.
find it.
I couldn't find mine immediately.
All right, so just so everyone knows, at the beginning, I always like to share the Google Docs that we're working with. So if you go and you look into the chat, which my chat's not coming up. Come on, chat. There we go. Here is the links to the Google Doc, so if you want to follow along on your own. Additionally, in this Google Doc, there are tons of links, so go and check them out. There's resources for you so that you can stay connected with the community, learn more, and basically help build what we're starting here in the greater Sacramento area in the Central Valley. I'm going to go back and reshare because I realized I only sent the YouTube link to Gary. Here's that YouTube link. So if you guys can get there, share the YouTube live, get, you know, people watching this and engaging. And I'd like to now kick off our CleanStart To-Dos by saying, welcome to the CleanStart To-Dos. Today we're going to have Dick Flask of RAF Electronics talk about their cool lighting solution. First, remember, if you're not talking, remain on mute. We pay attention to the raise hands features, and always feel free to put questions or talk in the Zoom chat. I'm going to be dropping links in there, so pay attention to it for that reason too. Agreements of an effective meeting space. I'm not going to go over all these, but the number one is kind of pay attention to your mic. I want to recognize our Clean Tech or CleanStart sponsors. These are the sponsors of the Clean Tech meetups: Blue Tech Valley, Sac State, SMUD, and Weintraub Tobin. I know Jeff is on here from the Wet Center in Blue Tech Valley. Jeff, do you want to give us a little description of the Wet Center in Blue Tech Valley?
Hey, good morning, Thomas, everyone.
I'm doing great.
Yeah, so we have a couple programs, including this Blue Tech Valley Innovation Cluster, one of the 4 statewide clusters to work with clean tech entrepreneurs and help them commercialize and develop their business in California. And then we have the Valley Ventures Accelerator, which will have our 5th cohort of some enterprising ventures in water, energy, and ag space this fall, doing some virtual accelerator events.
All right. Thank you for that, Jeff. They're also the ones that are partnering with us on the CEO crash course. So, oops, see, everything has a link to it, including to Blue Tech Valley.
There we go.
All right, so here's our announcements. Our next CleanStart ToDos is at 9 a.m. Hold on one second, I'm hearing a little feedback. All right, so this Thursday at 9 a.m., we've got open grants. Sidel, they were actually recently recognized in Comstock Magazine with being the startup of the month. They have a platform to allow that basically is an easily searchable place to find grants and grant writers along with partners to execute them. So this is a great place to go to learn about ways that you can help get grant funding for your business. Additionally, I'm going to drop a link in the chat. They recently released an article that I found really enlightening about how to restore prosperity, highlighting the successes of many of the grants that we have seen come out and how a lot of the technology that we have, this is kind of where it originates. All right. Additionally, next week, we got our Clean Tech Meetup, Electrification. I'm excited for that. We've got some cool companies that are going to be talking about what they're doing. Additionally, we have the CEO Crash Course coming up. That's CleanStart's partnered accelerator with Blue Tech Valley. Applications are due tomorrow. A little hint, we will leave the application thing up for a little bit past the 20th, but we will be really starting to look at everyone who applied on the 21st.
Yeah, so if you know of anybody that is thinking about starting or has just started a clean tech company, make sure they know about this because it is free, and I think we're up to probably about 15 participants now. So there aren't going to be that many more slots available. So be sure that people get their applications in soon.
Yeah. So please share that with people. It's going to be really useful to helping accelerate your company. Additionally, I wanted to highlight Weintraub Tobin has new update on PPP forgiveness, and HaneyBiz, I kind of threw these in at the last second. They have several webinars on making sure that you do your PPP forgiveness correctly. Even they address the bookkeeping in it, which is really helpful if someone wants to, they say like, show that you use this money just for payroll. You bookkeep it right, that's an easy report to run. Also, the Carlson Center has their Entrepreneur Toolkit series back starting tomorrow. I really suggest you go and sign up for this. Great way to learn more about customer discovery. I know Daniel Clark, who's here, went and attended the last of them. Did you find it helpful, Daniel?
I did. It's really helpful. I think finance side of things is almost like having another leg. So we did stuff like that at Brightlands Innovation Factory in the Netherlands also, and it's really great to refresh on it. I might join it again also.
Great.
Excellent. I know I'll be there. Also, Moss Adams has regular classes online classes that I suggest you go and check out. These ones also include how to fundraise or how to handle fundraising during the COVID issues we're facing now. Also, Startup SAC Happy Hour. This one's really exciting. One of the most successful companies in the Sacramento area, Trifecta, with over 150 million in revenue. We'll be talking about how they became successful. I know Laura's here. Does Laura want to I hope that's Laura good. Another Laura's fine too. But...
Yeah, it's me. For some reason, I couldn't get Zoom to launch today, so I'm watching via the browser. But actually, Greg's not going to talk so much about how Trifecta became successful. He's going to share his secrets of inbound digital marketing, which is how they became successful. So it's really going to be a how-to on inbound marketing.
So that's even better. And that's even better because that means you get to. Hold on a second.
Hey, you're echoing again.
I'm going to mute Andy there. That's where it's coming from. because that means you get to learn about how you can become successful and you can become the next, what are they called? Unicorn of the Sacramento area. Now, I want to encourage everyone to stay connected socially. Now, if you can go in here, please follow, like, share, sign up for our newsletter. I'm going to put a link to our newsletter in the chat. Connect with CleanStart, connect with Startup Sac. Here's a link to their Startup Digest on this page here too. This is how you can stay on top of things. This is how you can learn about the latest announcements. If you're an energy company, because I know a lot of you are, I suggest you go and click on this one, which is Empower. It's another network for getting connected in the digital space with a lot of the CEC programs and a lot of the funding. So without further ado, I'm going to welcome Dick Flask, president of RAF Electronics. Now, I'm going to let Dick shares his screen, but in these slides that I shared with you is his title page or slide, which if you click, you can actually go and check out his slides on it. Okay. So welcome, Dick. I'm going to stop sharing so you can start.
Okay. Let me get some, yeah, let's see. We have you still in the upper, okay, got it. All right. Well, good morning, everyone. Thank you for having me here. I thought I would run through about 10 minutes of slides to kind of explain what RAF is doing. So we'll get rolling on that now.
You still need to share your slides. You still need to share your slides. Click the share button on your slides. It's still not sharing them yet.
Oh, it's not?
Nope.
Well, I don't see any share button, and
would you like me to share them and you can tell me to click through?
Wow. Okay, don't know what happened.
All right. Well, I'm going to go ahead and
you can share it, and we'll do it that way.
Okay, give me 1 second here. Going back to this. All right.
Okay. All right. Now.
No, I can't see the slides. Okay, let's try something else here. Well, it worked before. Okay, well, this is good enough. All right. Again, good morning, everyone. And I thought I'd run through some slides, take about 10 minutes to introduce you to RAF Electronics. About 20 years ago, I was starting working to develop light engines for projectors, and I ran into a problem. One would think using the standard toolkit that you could take light from a light source, squeeze it down as much as you wanted, put it where you wanted on a micro display or through an LCD panel and project it. Turns out that I was having trouble doing that with the standard toolbox, and in fact, the whole industry was having problems with that. And that took me to on another adventure, learning about unconventional optics, or optics that was not as well understood as the standard toolbox. And we'll be looking at that. What we're doing right now is we're pioneering new technology to dramatically improve directional lighting, and specifically increasing the efficacy or efficiency of lighting, so that our fixtures are 10 times more efficient than bulb fixtures or filament fixtures, and even twice or 3 times as efficient as current LED fixtures. If we go to the next slide. Okay, and our mission is to commercialize these ultra efficient directional lighting products. We want to bring jobs and high technology, or jobs and proprietary high tech to the Central Valley, and especially disadvantaged communities. And we're doing this by combining the public grants like CALSEED with local private resources. Next slide. And the question is why and why now? We have opportunity drivers that have come up that allow this to happen at this time. We have economic drivers with this technology that will lower the energy costs for both consumers, ratepayers, utilities. We have societal drivers with some of the grant programs, especially looking to increase the jobs and opportunities to disadvantaged communities. And the lower energy, the higher efficiency, higher efficacy of these bulbs will, fixtures will decrease the greenhouse gas emissions. We have market drivers. In the markets that we've selected, there's a recognized but unmet need, especially in the directional lighting market and the specific segment that we've chosen as our initial market segment, which I'll get to in just a second. And then the technology drivers. We have an opportunity here because we have a proprietary patented innovation, and it's based on non-imaging optics instead of imaging optics, and on a fairly exotic area called étendue matching. And I'll get into that in just briefly in a second. Next slide, please. If we look at our market opportunity, we've chosen as our serviceable, obtainable market the theatrical spotlight market, with a MVP of the theatrical spotlight, which is really the workhorse of the theater. There are other types of lighting in the theater, but the spotlight is kind of the ubiquitous workhorse. We've chosen that as a beachhead market. That market is about 170,000 units a year, representing about $130 million a year. That sits on top of the general LED directional fixture market, which is about 75 million units a year, or almost $1 billion a year. And that's part of the total available market, which is all directional lighting at about $5 billion a year. Next slide, please. So these theatrical spotlights can be used in a variety of sub-markets for live entertainment in clubs or outdoor concerts, schools. Every secondary school, or almost every secondary school, has a theater in it. TV and movie studios, churches, cruise ships. But the primary market that we're going after, or had planned on going after, was the traditional theater, live theater, regional theaters, community theaters, university theaters. Now, we may have to rethink this with the COVID-19, depending on what happens with live entertainment in the coming years. But right now, we're still looking at theaters as the primary market that we want to initially go after. Next slide, please. If we look at the basic problem with the current theatrical spotlights, they run blazing hot. You can fry eggs on them. They're power hungry. They take about 750 watts. And you may have 100 of these things during a live performance. So you can be using a better part of a megawatt while the show is on. And the current theatrical spotlights are high maintenance. You have to change bulbs. You have to change what they call color gels, because the color gels fade under the high heat and the high intensity, especially UV light or IR light coming out of the current spotlights. So we have these three problems. They're hot, they're power hungry, and they're high maintenance. Next slide, please. The solutions that we provide, number one, our spotlights run cool. They can be touched. They're basically only a couple of degrees above room ambient temperature. We have a 10x power reduction. Instead of 750 watts, we run about 80 watts. And we can offer a 10-year warranty with low maintenance. These are solid state emitters. They don't burn out. They have 50 to 100,000 hour lifetimes. And the whole fixture is essentially calibrated and locked in at the factory. So there's nothing to get out of adjustment or have to fix during operations. Next slide. Where's the magic? It's in the outside the box optics. Optical technology that's not generally known by your average optical engineer. It includes non-imaging optics, and it includes something called étendue matching. Won't get into it too much, but non-imaging optics says basically if you have optics like lenses and reflectors that you require to transfer an image with some structure like the house of cards on the left there, that's an added requirement that's not necessary if you're just using this as illumination. You can collapse that house of cards into a deck of cards and get a much denser, i.e. brighter area. So by eliminating the imaging requirement, we get a big bump in the actual efficacy or the collection efficiency of the system. Étendue matching is similar to matching the diameter of water pipe. Every element in the optics system should be étendue matched with every other element. If you have one narrow bottleneck like you could have with a plumbing system, that'll restrict the amount of light getting through the system. So to guarantee both minimum size and maximum efficiency or efficacy, you need to étendue match all of the components in the system. That's really what the magic is in the box or outside the box. Next slide, please. Our competition, there are 4 family-owned companies that dominate the theatrical spotlight market. They all have similar products, either traditional LED spotlights using filament bulbs or LED spots. And we can outperform them all. If you look at our spotlights, we have efficacies, net total efficacies of the instrument of 130 lumens per watt, compared with 15 lumens per watt for traditional spotlights, less than 50 lumens per watt for LED spotlights. We're brighter. We take a small fraction of the, use a small fraction of the power that others do. We run cool. They run either blazing hot or warm. And our color quality, we have a high CRI. It's a full spectrum. And one of the disadvantages of the LED spots is that they have a banded spectrum that some people find objectionable. Our barrier to competition, we have an innovative technology that no one else has or is using. We have proprietary design software. We have patents, which is an important aspect of this. And we also have no boat anchors. And by that, I mean, we've not made the business decisions that take us in a different path as the other 4 family-owned companies have. They're going down a different path, and it'll be very hard for them to change direction and compete with us in this particular market segment. Next slide. If we look at our value-enhancing milestones, we have a patent that's been issued in 2016. We showed in 2018 a lab prototype at our trade booth at the US ITT trade show and expo. We have our results published in IEEE, a peer-reviewed magazine, and the authors on that were not only myself, but Roland Winston and Jonathan Ferry from the University of Merced, or UC Merced, I'm sorry. And they were instrumental. They're one of our team members. So we published a joint paper. We've been awarded the $150,000 grant last year from CALSEED as a concept award. We're now, we've been accepted into the competition for CleanTech Open, and we will be competing for that as well as the $450,000 CALSEED prototype grant. We expect first sales in 2022, positive cash flow 2023, and an annualized sales level of about $14 million a year and growing in 2024. Next slide, please. Our team is RAF Electronics. I started RAF Electronics about 30 years ago. And we've had to reinvent ourselves a couple of times during those 30 years, but it's been an interesting ride. We have our Central Valley team includes Blue Dolphin Engineering in Fresno, the UC Merced Solar Institute, Professor Crafassi at the Theater Arts Department at Fresno State. We're associated with Blue Tech Valley, having an office there. And we've also been working with Fresno State Business School. They've been helping us put together the business plan and some of the financials, and actually looking at some of the market segments. Next slide.
Hold on 1 second.
Wizard in Residence. I like that title.
I do too. I'll show you some card tricks next time we get together. Our rollout plan. Pardon me?
No, you said okay.
Okay. Our rollout plan includes getting or winning the $450,000 CALSEED prototype award, as well as locating about $1 million in other outside resources or funding. And we expect to have the alpha units ready by late June, early July this year. Should we win the CALSEED 2 prototype funding, that we expect the funding to be available the beginning of next year. It'll be about 6 months after that the beta units will be available. And we will be testing the beta units, sampling them to potential customers and getting feedback, probably do 1 rev on that. You'll see a little capital equipment blip in Q2 of 2022. That's when we have to invest in hard tooling for the injection molded plastic parts. Sales starting in the Q4 of 2022, and reaching a positive cash flow Q3 of 2023. Our goal is to reach positive cash flow as quickly as possible with a minimum of cash invested, and while keeping lean and mean and keeping fixed costs to an absolute minimum until that point. Next slide, please. And this is the contact slide. RAF Electronics. Again, my name's Dick Flask. Our primary office is here in my home in San Ramon, California. Our team is in the Central Valley, and that's where we intend to set up manufacturing. My telephone number, email, and the company website. We'll say the company website has had problems. It'll be difficult finding it if you do a Google search because we've had some problems in the website design. Those should be being fixed as we speak, and hopefully will be showing up more prominently in Google searches in the near future. But thank you very much, and I'm open for any questions if you'd like.
That's great. We've all learned a new word, étendu. So I don't know that that's going to have a lot of application in the work that we do, but I'm going to remember the word. I'll pull it on somebody. And some questions here. Daniel Clark has asked one, and add that to some others. What's your next move beyond theatrical lighting? Daniel's asked about holographic 3D projection. I'm thinking about, what happens, stadium lighting, which seems to be somewhat directional, and it's a huge power consumer as well. What are your thoughts on where you go after theater buildings?
Right. The arena lighting is an attractive market. It's an interesting market. It's a little bit hard to get into, but they have a huge problem with energy draw. It turns out we've done some market research in that area. The arenas are always blowing fuses. They're always overloading their electrical system. And the idea of being able to cut their electrical use in half or by a factor of 10 is a huge advantage for them. So that's something that we would look at. But what we will probably wind up doing is looking at directional lighting for architectural use or commercial use on the outside of buildings. We're focused on directional lighting, not general lighting, or not area lighting. So anytime you're talking about directional lighting where you need to collect a lot of light efficiently and put it where you want it, that's where we come into play. There have been some suggestions that we look at other markets, and we will do that in terms of just even desk lamps for rural areas or third world areas where power consumption is critical, or even flashlights for first responders where battery lifetime and brightness is critical. The advantage of what we're doing is that we collect virtually 100% of the photons coming off the solid state emitter, and we put those photons where we want them. So there's no spill light, there's no wasted light, and we use very efficient solid state emitters to begin with. So those are some of the other areas that we'll be looking at.
I know you said you had to get out of here at a certain time, Dick. So I want to be kind of respectful of that. How are you doing on time?
I'm fine for right now.
Okay. I had a question. So I've noticed a lot of the stuff you measure the brightness in lumens and not lux, which is lumens is total brightness. I think lux is brightness over a certain area, correct? Since you're using a lot the étendu and the kind of directional lighting about it, do you have anyone asking specifically about, like, I need this spot to be this bright, or because it feels like that would be a bad comparison for you to compare lumens versus lux for directional lighting?
No, that's not a bad comparison. In the theatrical industry, people use lumens, and they only use, the marketing people will only use lux if they can't achieve the lumen benchmark. In the theatrical industry, for a spotlight, you want 10,000 lumens output. That's kind of the standard that's been there for decades. Now, some of the new LED spotlights can't achieve the 10,000 lumens out because they don't use non-imaging optics and aton-due matching. And some of the newer LED spotlights will sometimes display the, from a marketing perspective, spec lux instead of lumens. You can do the conversion. It's a little bit awkward, but it can be done. And we always come out on top with, in terms of lumens, which is the important feature. The lux, you can artificially exaggerate it if you give not a uniform field, but a peak field. If you want a hot spot in the middle, and that's where you're going to measure, you can always make an optical system that gives you a hot spot in the middle, take the lux measurement there, and then you can claim a high lux value. But that's not really all that useful in the real world. What we can do, one of the aspects that we have other value propositions other than just the three that I showed. And one of those is that we can select either a very flat uniform field, that is the light is absolutely flat across the whole field and then drops to zero immediately when you hit the edge of the field. Or we can give selectively a bell-shaped curve, or a cosine curve, as they call it, where there's a slight brightening in the middle. And that's sometimes useful if you're going to use multiple spotlights to illuminate an area where the spotlight pool of light, where they overlap. If there's not a cosine distribution, then you can get slightly brighter spots around the stage. So we can with a simple switch selection, the spotlights, our spotlights, can either have a uniform flat field or a peaked cosine field. But in either case, you don't really want a very sharp peaked field in the middle, and then do your lux measurement there, because that provides a non-uniform illumination over the stage. That was a long explanation. Sorry for that.
That was good.
But I'm a propeller head. What can I say?
Hey, Dick, this is Daniel. I have a quick question. So I heard you say you're taking like the optics lens out. I have two questions. One, when you take that lens out, is that helping you display a higher amount of lumens? And number two, have you looked into phase light modulation? So we actually modify a DLP projector to emulate a spatial light modulator where we can software control each pixel in 3D. So for example, the question that Thomas asked before, can you control the pixels of light or the lumens of light in different shapes or different areas and different intensities? Is there some kind of similarity to what you're doing? Is it similar to like a projector, or is it just improved electronics?
Sure. Thomas, if you still have the appendix slides, I'd like to go to, boy, I'd like to do it myself, actually. Let's.
I think it'll probably be quicker if I get it up because I have
Okay,
it right here.
all right. I think it's the second from the last slide, or maybe the third from the last slide.
Right. Well, I bring it up. There's another question that might be easier or quicker for you to announce from Amita. How long will it take to be in production? If you had a client, what's your timeline for delivery? So I'm going to get the slides up so you can answer the other one. But
Okay, I'm sorry. How long to production? If
if you had a client, what is your timeline to delivery?
It's not so much a matter of a customer being the long pole in the tent. We've already had discussions with, for instance, Disney Cruise Lines, and they seem quite interested. I think I don't want to minimize sales and marketing whatsoever, but I think the long pole in the tent is really going to be the finding the resources in terms of money and whatnot. And if you look at our the slide, the rollout slide, could you go back to the rollout slide, which is
This one, or were you looking at this one?
yeah. That's one back again. Oh, okay. Well, either one of those. Yeah, this is about as fast as we think that we can put things together from a business funding and just building the infrastructure, both physical and financial, to get the annual sales. So we think that the first sales will be in 2022. Specifically, if you roll back, if we go to that rollout slide again, you can see what our the slide. Yeah, right. We show sales starting in the fourth quarter of 2022 into the third quarter. That's about as fast as we think that that we can get it out. It's if funding comes in quicker, we might be able to collapse that down by 6 months, would be my best guess.
Okay, now to when the index comes up on this. My Zoom just eats my computer's bandwidth.
That's interesting. Disney is interested in that.
Yeah, they have a big program to reduce energy consumption, especially on board cruise ships, because they have to produce their own energy. They have to produce their own power on cruise ships. Of course,
Okay.
cruise ships are not are a little problematic when at this point in time with COVID, but we kind of expect the COVID thing to blow over in the next year or so. So we're not changing our business strategy yet, but we're aware of the fact that we may have to.
So which one of these did you want?
Okay, let's see, it's around slide 22, I think.
Disney also has a volumetric 3D printing patent like us.
Oh, very cool.
Okay. Yeah, this is the one. Although, that's a little strange. Okay. I don't know why there's a shaded rectangle there, but basically the RAF theatrical spotlight, we have a solid state emitter, we have a non-imaging optic, which is, it's a reflector, but it's not a parabola, it's not an ellipse, it's a very, it's a shape that can only be approximated by a very high order polynomial, and it's an interesting non-imaging optic reflector. At the end of that, there's a gate or gobo region. A gobo is a pattern that's you have to be able to project a pattern with a spotlight onto the actual stage or onto the wall. So that gate is where the gobo goes. And one of the interesting aspects of this spotlight is that right now the gobos are made of steel because their spotlights, the typical spotlight will essentially melt anything else, or they can be made of very high temperature glass, and they cost about $400 a piece. Because our system runs so cool, the gobos can be inkjet printed from PowerPoint, and you can just use those celluloid gobos, and that's a huge advantage for the customers. That's one of the big things that we got out of the UC Fresno Business School. But after that, so that's the non-imaging optics. We also have imaging optics there because we need to transfer the image of the gobo to the wall or floor or wherever. So we do have a couple of imaging lenses in the lens barrel of the spotlight itself. So it's a combination of solid state emitter, non-imaging optics, imaging optics, but every component in that whole light train has to be étendu matched to achieve the high efficiency and minimum size. So indeed, you could put this is kind of like a projector. You could put some type of light valve in the gobo plane and project an image out onto the stage. We were thinking of that, and it would be possible to just throw in an LCD, an active matrix LCD imager at that point and project it. Of course, LCD imagers, they don't, at best, when they're turned on, they allow about 5% of the light through. So, our 10,000 lumens would be reduced to, 500 or 1,000 lumens. There are potentially on the horizon other light shutters that may be more efficacious than that. And certainly you can think about using our non-imaging optics and étendu matching approach to actually illuminate a DLP light valve and then project from that. In fact, that was when I said I was starting 20 years ago to work on light engines and ran into this problem. That was exactly the system that I was looking at, is developing a light engine for DLP. So it is possible to use these techniques to develop light engines for DLPs and improve the overall performance of the DLP projectors. But the biggest bang for the buck, where we have the biggest value proposition advantage, is still right now in the theatrical spotlight market. But that certainly is another potential market.
Thank you for that. That's a great answer to a lot of it. In the chat, there's another question, but I want to make sure that we're respectful of everyone's time as we're pushing it towards 10 o'clock. I want to make some quick announcements, and then I'll leave this kind of open. Remember, we've got open grants this Thursday at 9 a.m. Click here and connect with us there. The Clean Tech meetup next week, startup happy hour. And if you want to one thing that we didn't get to talk about that I thought was really interesting about the growth of RAF Electronics is you partnered with a lot of the CSUs and the colleges there to help move your product forward, right? Correct, Dick?
Yes.
Yeah, so I shared a blog in the chat where we kind of talk about that. I'm going to share it again too. And also, if you kind of like what we're doing, make sure that you sign up for our newsletter. I'm going to put a link to that in the chat too, along with a link to the next to do later this week. Yep. So make sure you stay connected. Check out the Carlson Center Toolkit tomorrow, or Startup Sack Happy Hour next week, and the Clean Tech Meetup. And get your applications in if you want to apply for the crash course. I want to give additional thanks to our sponsors who enable us to put on these events, from EY, who they're actually going to have it to do next week, to Stoll Reeves, Moss Adams, and Hacker Lab, who actually house us when we're not doing safe social distancing. I want to thank everyone for attending, and now I'm going to read off Amelia's question, which is, so what is the cost of delivering for a cruise ship, provided you are still in the R&D phase?
I'm sorry, the cost of delivery?
So if you look in the chat, her question is, or if you're here, do you want to just unmute yourself and go ahead and ask your question, Amelia?
Oh, well, okay, I can see the question in the chat. We're not really delivering a service to a cruise ship. The product that would be delivered to the cruise ship would be a set of spotlights. So the cost of the spotlight is comparable with the cost of the current bulb spotlights. If you looked at the competition page right now, a traditional bulb spotlight retails, the ASP is about $500. Our cost of sales is about $250. We could compete with the traditional spotlight, the 750 watt spotlight, on a dollar for dollar basis. The market analysis from Fresno State told us that we should not try to do that, that we should set the price point for these new RAF spotlights at about $750 to provide some sense of differentiation from the traditional bulb spotlights. So the cost of sales is about $250. The ASP that we're targeting is about $750, and that the spotlights are basically the same whether they go on cruise ships or in theaters or churches or high schools. So it's kind of a standardized lighting instrument.
Gary had to run. Does anyone else have any questions for Dick? All right.
Well, I want to thank you very much, everybody, for coming, and thank you, Thomas and Gary. It was very enjoyable and beneficial for me. Thanks.
Excellent. Like and share our things and check out their website. All right. Bye, everybody.
Thanks, Dick.
Yep.
Yeah.
Thank you. Bye-bye.
Thank you very much. Take care.
Bye.